Let's take a look at Leet code 208, implement trie or prefix tree. And this is a great question to be able to practice your tree data structure. We've been seeing a lot of binary trees, and a trie is a string related tree which allows you to better search for strings such as autocomplete and spell checker. So a trie or a prefix tree is a data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. So in this question, we need to implement the trie class. So we have a class which we can instantiate to initialize the trie object. And then we can go ahead and we can have these common methods. So we can insert, which inserts the string into the trie. So thinking in terms of a tree structure, we're thinking of inserting a character into each node, and then that has children, which corresponds to another character, and so on. Then we have the search and starts with functions. So search, it returns true if you've previously inserted a word before. So you're able to search through the trie that you've created, and if the letters are there and you've marked the end of a word, that counts as a search retrieval. And then we got starts with, which is similar to search, but starts with is where you're just looking for a prefix. So there could be letters after that, but that doesn't matter because we're just searching for the prefix. So there's a clear distinguishment that needs to be made between the search and starts with, and we'll see that in the code. So we can see that we've been given this boilerplate of the trie class, which has a constructor, and then it also has the three methods that we want to create. It has insert, search, and starts with, and then it has an example instructions of what we want to achieve after we fill out those methods. So basically we want to instantiate the trie class, and then we want to insert a word into the trie, which is going to take all the characters in the word, and it's going to make it into a tree structure. And then we want to be able to search for the word. Now it's very important to note that search, it's searching for the word being completed. So if you put in the word apple, A-P-P-L-E, and then you search for the word app, that does not count as a search, but that would count as a starts with. So that's the difference between the two methods. Starts with just looks to see if the letters are in the tree, and search searches to see if the letters are in the tree and the last letter has been marked to signify that a word has previously been entered into the tree. So let's just go ahead and clear those instructions up. So basically a trie is a tree data structure where each node is composed of characters, and each node has unique characters as children. So I'm actually going to create another class for the node. So I'm going to call this trie node, and trie node, it's going to have the children. And as mentioned, because the children are unique characters, we can use a map to map the character or string in JavaScript. And it's going to reference itself in the same way a tree data structure can reference itself, or a tree node would reference itself, where each of the children corresponds to a trie node. So, for example, the very first node is going to be the root. So in our trie, we can, and I might just tab this back one, we can say, well, we want the root node because we need to have the root node so we can traverse through the tree that we're yet to create. So basically, we, in the constructor of the trie, we want to just set the root node equal to a new trie node. So that way when people create a new trie, we have access to the root, and then we can do things from that. So these three operations here. So essentially, since we've created this first try here, basically we need to, well, the root node, it doesn't have a value itself. The value itself is related to its children. So basically we want to have a constructor in the try node, and we just want to set this children equal to a new map of this form here. And recall that for search that we need to be able to detect wherever the word has previously been entered in. So not just the letters, but the actual word itself. So we need a way to be able to mark the end of a word, and we do that by on the try node. So the try node represents the character. On the last character, we need a way to be able to detect if it's the end of the word or not. So I'm just going to have it is end of word, which is a Boolean. And then in our try node, we can say, well, this end of node, or end of is end of word, we're going to set that to false by default. So that means when we create a try node, is end is going to be false by default, and the children's going to be a new map. So it's initially going to be empty, but then we're going to use the insert method to be able to insert into that. So now we've actually composed our data structure. Let's go ahead and begin to work on these methods here. So let's start with insert. So insert, it takes a word and we need to compose it into the tree. So right now we've just got a root node, and the root node is a blank empty node. And then we want to take each character of the word and make it into a tree structure. So to do that, we first need to get hold of the root node. So I'm going to say let node equal to this root, and we're going to need to traverse through the tree if a word's already inserted. So if we've already inserted the word app, for example, app, then we want to insert the word apple, well, we would already look at the nodes A and P, and then after that we'll be able to insert L and E. So that's in the second case. So we need to be able to loop through each character of the word, and essentially if we see that the node has no children with that particular character, so recall we've made that map data structure here, so we're looking for the particular character of the word here in a key lookup, and we want to get the corresponding try for that word if it exists. But if it doesn't exist, it means that word hasn't been, or that character for that position in the word hasn't been added to the try data structure just yet. So if that's the case, what we can do is we can simply add it, and we can do that because we have access to the node and we have access to the children, and then we can go ahead and we can set that character to a new try node as well. So the new try node is going to have children of its own, and then that just ensures that we have the right data structure matching to this type here. So basically that's in the case that no words have been added, or that word or the characters haven't been found. So if they have been found, well, regardless if they have or haven't been found, we need a way to be able to go to the next node. So basically what we do here is we say we want to set the node equal to the children, and then we just want to get the particular character that we're on. And then after that, outside of the for loop, we can say node is end of word equal to true. Okay. So that means we've made it to the last character in the word, and then we can mark that as the last is end of word. So then when we traverse through the tree to search, we can actually tell if it's a word or if it's just a prefix. So let's go to the search method here. So the search method, it is looking for, we need to traverse through the trie, so the nodes of characters for each character in the word, and then we need to look through to see if that word, when we traverse through the tree, if the last traverse character marks an end of word, in which case we have a word. So to do that, once again, we can actually copy some of this code up here, and I'm going to copy this here. So basically what we can do here is we can just return false if that's not the case. So we pass in the root node, we loop through the characters of the word, and if there's no children of the node which has the character, that means that character hasn't been entered into our trie or tree data structure of characters just yet, which means the word doesn't exist. So we can just say, we can return false, the word doesn't exist. However, if it makes it past that, what we want to do is we say, okay, well, we want to, once again, we want to set the node equal to the child, so then we can continue to loop through. And then when we loop through again, basically, it'll keep looping through until we get to the last character of the word. And if it makes it past all of that, so outside this for loop here, which should have a closing bracket, if it makes it out of that, then we can simply return true if it has if the character has or the trie has the is end of word, or false otherwise. So we can return the node is end of word here, which will return true in the case that, we've previously inserted a word and then that last character on that node on the last letter has that mark there. So then we can return true. So that's in contrast with starts with, because you might have all of those letters, however, it wasn't previously entered. So the example I gave before is if you entered the word apple, but then the next word you're searching for the word app, or you haven't entered that into the tree, so the second P in the word app, it wouldn't have the is end of word marked, therefore that would return false. But this starts with is looking to see if that prefix exists. So rather than searching for the full word completion, those letters APP, that does exist because the words apple, the letters apple have been entered as nodes into the trie and the characters representing them. So what we can do is we can actually essentially reuse this code here if we just add a little tweak, because we can add a is prefix variable here, or parameter, and then we can set that argument to false. So basically using this is prefix flag, we can actually say, well, if is prefix return true, because we would want to return true if we're just doing a starts with looking for the prefix, because if it's made it to here it would be true, otherwise it would have returned false before you got there. Otherwise you return the node is end of word, and since this is false by default, if you're just considering the search method, this will be false, but then it will evaluate this condition here, which means the starts with method can be simplified to just returning this dot search and then passing in the prefix and also just passing in the true flag here. So let's go ahead and submit this code here, and we can see that it was accepted.